y vamos a presentar al Keynote Speaker del segundo día, al señor Jeff Crume. Él es ingeniero y máster inventor con 35 años de experiencia en la industria TI, autor del libro Inside Internet Security, What Hackers Don't Want You to Know, y coautor de Information Security Management Handbook, miembro de la Academia IBM de Tecnología y parte de la Junta Editorial de Information and Computer Security Research Journal. Demos la bienvenida a Jeff Crume, por favor.
Gracias. Buenos dias. Thank you all for being here. I'm sorry I have to switch to English. If we do this in Spanish, it's a very short presentation. So we will switch to English now. I will try to have some time at the end for questions. If I don't get to answer all of those, then feel free. I have my email address posted at the bottom of the presentation, and you can contact me that way as well. So this topic that we're going to talk about, cybersecurity and artificial intelligence, two independently very important topics. A lot of interest in cybersecurity because the bad guys keep getting better at what they're doing, and a lot of interest in artificial intelligence because, quite frankly, it's something that in a rare situation, the good guys have an advantage here. Most of the time when there's new technology that comes out, the good guys can use the technology to defend, the bad guys can use it to attack. Now, it's not to say that AI won't be able to be used in attack. It will. But right now, AI is much more geared toward defense. The companies that have been able to invest in AI and create the benefits there have been on the defense side. So this is a good news story for us. It's one of the few cases where we actually have an unfair advantage against the attackers if we use it. So let's talk a little bit about what that is. So the trends are not going the way we want them to in the cybersecurity space. The threats continue to increase, the number of alerts continues to increase, but our ability to address those continues to go down. We don't have enough people to do the job. We don't have enough knowledge to do the job because the knowledge base is constantly changing. Every day there are new types of attacks and no one can keep up with all of the different types of attacks that are out there. And the amount of time is going down. Now, we have the same amount of time we've always had, but the immediacy, the urgency to fix the problem in order to minimize the damage, that becomes more and more important. The statistic that you see at the bottom of this chart says that by 2022, now think that's less than 4 years from now, we'll have 1.8 million cybersecurity jobs that will be unfilled. We cannot create cybersecurity experts fast enough to fill that gap, even if we start right now and do a special emphasis, which many companies, many schools and universities are trying to do this. We're still going to have a gap, and it's going to be large. Now, there is no gap on the side of the guys attacking. The gap is on the side of the guys defending. So how are we going to deal with that? I'm going to suggest to you that we need a way to be faster, a way to work smarter. We need something that will be what we refer to as a force multiplier, something that magnifies the capabilities of the people that we do have and allows them to accomplish the same job or more in the same amount of time. And that's where artificial intelligence can come in. Because, see, this is the kind of threat, or the kind of task, I should say, that the good guys face on a regular basis. We see an attack come in, and someone in the Security Operations Center needs to go analyze the information. And in order to analyze, there's a lot of different steps. And each one of those steps requires more and more time. We see an alarm, we go off and research this. Then we research this aspect, and then we do a little more information and pulling all of this in. It's a very manual process today for most people. So how could we improve this type of dynamic that takes a lot of time and that we have to keep repeating, and that if it's manual, it's also potentially very error prone. So we may miss certain aspects that are important in the investigation. Well, the answer is, again, we think artificial intelligence can help in this problem. It doesn't replace the human operator, but it augments their ability and increases their force, their ability to solve these problems. So artificial intelligence, I find, is an area that you will, especially if you go to vendor conferences, everyone claims they're doing this now. Some of them are true. Not everyone is doing artificial intelligence. Some are doing traditional computing, and they're calling it AI. So let's talk about what is AI and what's not. Well, it turns out, here are some basic definitions. According to the Webster Dictionary, it's a branch of computer science dealing with the simulation of intelligent behavior in computers. It's a very simple definition. It makes sense. We can all agree if a computer looks like it's being intelligent, that's what we're going to call artificial intelligence. But what is intelligence? And that becomes a more difficult thing to define, because in fact there are many dimensions to intelligence. The Oxford English Dictionary gives a little longer definition. It's the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as, and now here are examples of intelligences, visual perception, speech recognition, decision-making, and translation between languages. So those are other examples, but those are not a full list of what would be considered intelligent. So what does all this mean in plain English, or in plain Spanish, if I could speak it? Artificial intelligence essentially involves making computers more able to match or exceed human intelligence in its various forms by mimicking the human ability to discover, infer, and reason. Well, we want to make computers at least as smart as us, if not smarter. So that's the idea. Now, AI is often referred to as if it was a monolithic, if it was a single thing. This has AI infused in it, this does not. And it's usually not as simple as that. Because I think what I'll challenge us to do is think about artificial intelligence technologies, plural, more than one technology, rather than as if it was, yes, this is AI, no, this is not. So for instance, here are examples. Reasoning and problem solving is one example of an AI technology. The ability to represent knowledge, the ability to plan. If you think about this in human terms, our ability to plan separates us from certain other living beings, and we consider that to be intelligent. We can think ahead to the next step. Our ability to learn. Because there's a difference between, for instance, a traditional computing system that we program. So in that, basically all of the intelligence is in the mind of the programmer, because the programmer has to conceive of what all of the steps will be. The programmer has done all of the planning, has done all of the reasoning in advance, and codified that in the form of an algorithm and put that expressed in a programming language. That's programming. That's not artificial intelligence. An artificial intelligence system is one that learns on its own, that reasons on its own. So we don't have to tell it everything, just like a child. When the child is very young, you start to teach it things, and at first it doesn't know anything that you haven't taught it. But as it gets older, it uses what it knows and its own experiences, and it starts learning on its own. Now, sometimes the child learns the wrong thing, and we have to correct it. And the same thing happens with artificial intelligence technologies. As they begin to sometimes learn and start to assume, and we have to correct those as well. Natural language processing, the ability to perceive the world around us, is a form of intelligence. Motion and manipulation, robotics, and things of that sort. Creativity, it's a really difficult one. With a programmed deterministic system, it's hard to create creativity because the outcomes have already been predetermined, unless we're using a random number generator, and then randomness is not necessarily creative. So these are some of the things that when we talk about AI, it involves all of these things. So let's not talk about AI technology, let's talk about AI technologies. And then we can start to have a more accurate description, I think. There are different categories within AI that you will hear frequently. So for instance, machine learning is a very popular one. You see a lot of products starting to use machine learning in the cybersecurity space. So machine learning is a subfield of AI, as you see here, and computer science. It has its roots in statistics and mathematical correlation. So we can take a certain set of data and then apply statistical analysis to it and then start to understand insights from that data. That's in essence what machine learning is about. Deep learning is a different form of that. And we see fewer examples of that, but nevertheless it exists. Now, cognitive computing is an area that overlaps in some of these areas. So a cognitive system would have elements of machine learning and deep learning, plus some other things as well. A cognitive system learns. It's not programmed. So that's an example of why we consider it to be artificially intelligent. A cognitive system has the ability to take in information in unstructured form and make sense of that, and then reason over that data, just like you would. If I hand you a stack of documents to read, you read that, you comprehend what it says, and then I can ask you questions about it. Now, sometimes asking you questions about it doesn't just mean automatic recall. For instance, you can look at some technologies like search engines. Search engines are designed to look for specific keywords and bring back the results of that. That's fine, but that's not the same thing as a system that reasons. So for instance, if you go to Google and say, show me pictures of everything except pink elephants, you know what Google's going to show you? Lots of pictures of pink elephants. Okay, I said everything except. Google didn't understand what my question was. It just looked at keywords and said, oh, he said pink elephants, let's give him those. Okay, so an intelligent system would be one that understands the context and reasons and gives you what you're looking for. So here's an example that shows some of these technologies. So we've got very low-end type of pattern matching capabilities like grep, search engines that I just mentioned, other forms of pattern matching, correlation and rule matching. So we set, again in advance, usually with these systems, what the rules are. And then thresholds, and when those thresholds are met, then we get actions. These are all very traditional computer techniques that we use, and we use these in cybersecurity, of course. Analytics is where we start to now add more statistical models. We start to look at behavior analysis. We can look and see if a user is doing something that is anomalous, something that's different today than what they've done for the last, say, 6 months. And look for those differences and maybe understand that something unusual is happening here. Cognition, a cognitive system, it builds on all of those but adds something else. And that is the reasoning capability. That is the ability to understand what these things mean and draw conclusions. That's a different level that we're talking about here. It's the kind of thing that until more recently was only possible by humans. And now we're seeing it being done by machines in limited ways. So we'll talk about some of those. How about AI in the real world? Not what we see on the movies, but what has actually happened in real life. So IBM built an AI system, a cognitive system, called Watson. And I think it was 6 years ago. We commissioned Watson to play the TV game show Jeopardy. How many of you are familiar with this show? Okay, most are. I'll try to explain it briefly for those who aren't. It's a quiz show where the contestants are asked questions, but actually what they're given is they're given answers, and they have to then determine what the question was. So already that's a little different. Again, if you go to a search engine, search engines are good if you ask the question They're not good if you give it the answer and then it has to come back and give you the question. So that's one twist that we as humans are able to do that's different than search. The next thing that makes Jeopardy very difficult, this game, is the wide variety of questions that could be involved. It could be everything from sports to language to culture to art to politics to history to geography, a wide variety of topics. So to win at this show, you have to be very smart about a whole lot of things and know a whole lot of things. But if you're just a good database and you can remember everything and you can read everything, you still won't win at Jeopardy. Because Jeopardy also uses what we call idioms or figures of speech, the kind of things that are plays on words. So the clue, if you take it literally, won't necessarily lead you to the right answer. You have to look at some of the clues and think, oh, but that's what it really means. This is kind of a twist of the words. So again, it's the kind of thing that goes beyond mere search, lookup, and retrieval. So Jeopardy was chosen as a challenge for our AI system for exactly this reason, because it's the kind of thing only a cognitive system would be able to deal with. A traditional search engine database would not be able to win at this because it wouldn't understand those nuances, those small changes. So we did this. We did it on live TV for the entire national audience, and we had Watson there in the center play against two of the best Jeopardy champions of all time, two of the very best players ever. And what were the results? They played 3 nights, and the results were this. Watson won, and it wasn't close. As you can see, Watson won by more than 3-1 in its score. And it's calculated in dollars because of the way that the wagers are done in the show. So for the first time, we had a computing system that was taking on a really different kind of grand challenge than we've ever seen before. It was groundbreaking. Now, what do we do with that? Because IBM's intent is not just to win game shows. We want to do something that's going to impact the real world, but this showed what the possibilities were. So let's talk about what can impact in the real world. What's more impactful? I'm sure there's not one of us in this room who has either not been personally or indirectly affected by cancer. It's a disease that takes so many far too soon. So IBM decided, again, let's not go for a small challenge, let's go for a big one. Let's see what we can do in terms of creating better outcomes for cancer patients. So we worked, and 60 Minutes is a news magazine show on TV in the US. If you want, you can look this up online. I included the link. You may be able to find the video now. Sometimes it's harder to find, but you can see the transcript of this. So this was an interview that was done by an outside news organization, CBS, and this is what they found. A project that IBM did with the University of North Carolina, the UNC Lineberger Cancer Center. Now, what happens in a place like UNC is patients come in and they're treated. And for those who can be treated, then we just do the standard therapies. There's always some set of patients who don't respond to the standard therapies. And for those, their cases are presented to a tumor board, to a body of experts who sit around a table and they analyze the case. A doctor comes in and presents the case, talks about who the patient is, what the diagnostic tools they have used, what they've determined, what treatments they've tried, and what results they've gotten. And then the board of doctors and cancer experts decides what should be the next course of treatment. So what we did was we took Watson and started teaching it the language of medicine, and specifically the language of oncology, of cancer and its treatments. And Watson took some time to learn this. Like I said, Watson will make mistakes just like a human does at first as it's starting to learn. But one of the challenges is, if you are one of these doctors on a cancer board, on a tumor board, there are 8,000 new medical research papers published every day. How is it possible that you could keep up with the current medical literature? The answer is you can't. Even reading 8,000 words every day and comprehending it all and remembering it all and bringing it back at the right point in time would be impossible for most humans. 8,000 papers a day can't be done. But Watson can read 8,000 papers a day. Watson can keep adding it to its corpus of knowledge. That's what we call the sort of database that it has in terms of what it understands. And so Watson is reading all of these papers and consuming this information as it's changing on a daily basis. And then what they did, because they're not just going to turn a computer loose to start treating patients, so they said, let's go back and look at 1,000 cases that have come through the tumor board and see what Watson would have told us had Watson been there at the time. And it turns out of those 1,000, Watson matched what the tumor board recommended 99% of the time. Now that's remarkable, that we now have a machine that can represent what the best medical minds would have said to a 99% degree. Now, I'm not sure if you had 5 doctors in a room, they would agree 99% of the time. So this is really remarkable that you have a machine that's able to match that collective recommendation. What was really interesting, though, that shows that Watson was effective. It wasn't doing crazy things. It wasn't recommending therapies that no one would recommend. But also, Watson was used, and it found in 30% of the cases additional treatments that the tumor board believed should have been tried. So it's suggesting and finding things that the humans weren't finding. So it became the force multiplier. Now, do we disband the tumor board? No. It's still needed, but this becomes a very valuable. Imagine a doctor who now sits in on this, who can say, yes, I've read every paper there is, and here's some additional thoughts to add in. It's a really nice second opinion that you can call in to have here. So we've talked about winning game shows. We've talked about treating cancer. What does all this have to do with cybersecurity? Well, let's talk about that. So if we think about the volume of information that we have available to us in the cybersecurity space, there's a lot of information that we have. The stuff that you see on the top of this slide is the tip of the iceberg. That's security events and alerts, it's logs, it's user and network activity, it's threat feeds. These are all very traditional sources of data for us about security. And what they all share in common is that they are structured. We know what a threat feed is supposed to look like in advance. We know this is this field will be here, this one will be there. The same thing with security alerts. We have protocols that tell us how they should be formatted, and they follow that. So we have lots of good tools. IBM and other companies have security information and event management systems that are designed to process this structured data. They eat this stuff every morning for breakfast. It's what they were designed to do. However, the problem is that that's maybe only about 10% of the available security information that could be used in these cases. So the other 80 to 90% of the information, if you take that and feed that into an SIEM system, it has no idea what to do with it. And by examples of that, you see listed. A research document, imagine a Word document, or a PowerPoint presentation, or a blog, or a wiki, or an analyst report, or any of those kinds of things. You take that and feed that into your security system, and what will it do? It will choke. It has no idea what to do with a Word document. You and I can read that because we possess the ability to do natural language processing and reasoning and comprehension. But that's not something that just comes with a machine learning system. So, in fact, what we're doing is we're missing a lot of information by limiting ourselves there. So the hope then is to create this sort of three-legged stool where we have the basic security analytics. That's what we've been doing with security information and event management systems, where we correlate the data, massive amounts of data coming in with security alerts and alarms and things of that sort. We look for particular patterns. We apply policies, and we look for exceptions to those policies. That's the anomaly type detection. We can use even things like machine learning to look for what those anomalies are. We prioritize the information, we visualize it, and so forth. That's what a security information and event management or security analytics system is designed to do. Then we have a human operator who has to make sense of that and decide which ones of these things do I act on and which ones do I not, and what type of actions do I take. So what we're talking about now is adding this third piece, and that's the cognitive security, the AI component that's able to do unstructured data analysis, that's able to process natural language queries, that's able to answer questions, that's able to do bias elimination. Think about that. We all tend to look at things and we find what it is we're looking for. It's sometimes hard for us to look for something that we're not looking for because we focus in on looking for a particular pattern. A system that eliminates bias, though, will look for whatever is unusual and find things that sometimes we won't. Many times we're looking for something, and because that's not what we're expecting, we don't find it. We just don't see it. So a system like Watson, an intelligence system, doesn't suffer from that same bias because it can process all the possibilities. So we take that information, fed to it, so it takes the data processed by the security analytics system, puts that in the cognitive system, and then it's fed up ultimately for a human to decide what do we do with all of this. Because yes, the good news is there's still a need for those of us that are the carbon-based units here, the humans in this equation. Because what we haven't found systems yet able to do very well is common sense. It's common to us. Some of those things are obvious to us, but maybe not so obvious to an algorithm or to a system that has learned by reading documents. The sort of morality of what's the right thing to do versus the wrong thing to do. The ability to prioritize amongst competing interests. Those are the kinds of things that are dilemmas for humans, and they're nearly impossible for computers at this point at least. So there's a role for all three of these kinds of, if you want to call humans a technology, all three of these kinds of technologies working together. So let me give you an example of how this could work. This is a very, very simple example, but it'll give you an idea so that this AI stuff Jeff is talking about is not just magic. You can see how you could get to this. So let's take an example of connecting dots. We know a domain resolves to a particular IP address. So www.hacker.com results in a particular IP address. We have a URL that we see points to a file, and that file happens to turn out to be a particular piece of malware. Now, what we could do is realize that this URL that we've been passed corresponds to this domain. And that domain resolves to an IP address. So anytime a user connects to that IP address, we connect all of the dots and we realize this user has probably or could possibly be affected by this particular piece of malware. That's a case where we had lots of discrete pieces of information that a number of different systems might have had for us, but we connected all of the dots here in order to draw a conclusion. So this is a knowledge graph that then we're able to use to make insights. This is one of the ways, one of many models that Watson uses. And we can then create a map of all the known entities and which ones are affected and which ones aren't. Now the map, the visual representation, might look like this, with all the red stuff being affected systems and the blue stuff being unaffected. Now this looks really impressive, but you can't actually use that. It's too much information for a human to process. It's not too much information for Watson to process. for instance, or for an AI system to be able to process. I keep using Watson as an example because that's the one that I'm familiar with. And ultimately, it takes from that then and looks for patterns, and some of those patterns then could ultimately lead us to conclusions. So an operator starts off with an alarm that comes in and says, I think this is a problem. It looks like I have a workstation that's been infected with malware. I'm going to send this off to my AI and have it see if that's the extent of the problem or is there more to it. And in this case, send it off and you come back with results that look like this. Results that don't show you everything in the network, it shows you only the affected portions of the network. All the way down to, in fact, we believe this was the first workstation to be impacted. This is the sort of patient zero. And we can see now how it spread. We can look at where the malware came from, we can look where it infected, and then we can look and see how it propagated. Now, instead of looking at an isolated incident, we're looking at a much larger malware campaign. We have a much better sense now of what needs to be addressed. Now, everything that you see there is something that could have been done. You know, it starts off with one incident. The AI system comes back and says, no, you have lots of these incidents. And by the way, if you want to know how I got to this reasoning, well, I'll show you how. And I'll show you my confidence in this as well. And here are the documents I use that describe the malware and how it spreads. So you can now learn from this if you're the operator as well. So a human could have done every single one of these steps. There was no magic here. But a human couldn't do it all as fast, as completely, and with as much of the latest news and information, and do it without bias. That's where this thing comes in. So we now have these AI systems that are taking outcomes that would have taken users. In some cases, we've had examples where a customer tells us it would take us an hour to do that investigation, and now we're able to do it in a matter of a couple of minutes. So why is that important? We go back to my original slide, and I talked about the shortage of cybersecurity positions. 1.8 million people that we need that should be on the job in 2022 that we're not going to have. Well, what we might be able to do is lessen that gap with AI. If we can do a 50 times faster investigation, as we've seen in some cases, if we can come up with 10 times more actionable threat indicators than we were able to do with traditional technologies and with humans doing most of the manual investigation, then now the gap gets smaller. And remember when I started off, I said, this is an unfair advantage for the good guys. This type of system makes it easier for us to do investigations in much faster time. And as a result, it's going to be harder for the bad guys to hide. Now, there's a whole other area of using AI and poisoning the corpus of knowledge and this sort of thing, where attackers will certainly try to use AI against the good guys. But for right now, we have the advantage. The attackers don't have the ability to invest in the kind of systems that can do this kind of work. There's a lot of really basic computer science research that goes into this, and in fact, there are very few companies that can do this at all, much less hackers who are trying to work on their own to do this. So building a security operations center that learns and can act more effectively, that can utilize these later technologies, cognition, the ability to think, not just be programmed, we feel like this is going to be a big answer and a big way to move things forward. If you'd like more information, I'll point you to the IBM website on security and artificial intelligence that you can see here. From that page, you can scroll down, and if you want a simplified version of this, then we have a Cybersecurity and AI for Dummies book you can download for free. If you want a not so for dummies version of this, This is the one that was written by dummies, but for smart people. Two of my colleagues and I wrote this frequently asked question document that's also available for download there if you're interested. And it goes into it in much more detail than I was able to do here in the presentation. And it also may be helpful to you just to have the words to see instead of having to listen to this American with his bad accent and try to sort through it that way. So feel free to download those resources if you'd like. And with that, my comments are done. So thank you, and I will stop and take questions. Thank you.
Thank you very much. We have time. ¿Tenemos tiempo para preguntas? Acá.
Yeah.
Adelante.
Thank you. It's an honor that you are taking the time to come here.
Oh, thank you. The honor is mine.
I come from the legal arena of cybersecurity. However, there are two main questions that internationally have been brought with artificial intelligence. One is, how do you respond on IBM to the dilemma of unemployment? Watson and other artificial intelligence can replace doctors, lawyers, scientists, and at the moment that you are advancing in artificial intelligence, you will have a big problem to respond to social and public interest. How do you deal with that? That's my first question. And the second one would be related to how do you respond concerning artificial intelligence and intellectual property rights? Let me give you a short example so you can respond to that. If I have access to different databases and Watson or other artificial intelligence systems can access that data, and for example, through medical records, you are able to come with a conclusion or opinion that challenge the traditional opinions of doctors. Who will own that kind of improvement on science, law, and other sources? Since through that you can monopolize knowledge, and that could be a big challenge for all these systems. Thank you.
Good questions. Thank you. So first of all, some disclaimers. I will answer those questions with my personal opinion. I'm not speaking for IBM when I answer this. So I like my job. I don't want to get fired. That's what that means. So everyone's clear. I'm answering as myself. Also, the second is I'm not a lawyer. I can pretend like I'm one. I've watched every episode of Law and Order on TV, so I feel like I'm qualified, but I haven't actually been to law school, so I'm not qualified to answer on the question. I will render my opinion as best I can do. First of all, we haven't seen, that I'm aware of, where these kinds of technologies are replacing people because, in fact, going back to the fact that there is such a gap, we can't replace what we don't have to begin with. So in other words, we need 1.8 million people that we can't employ because they don't exist. So the concern is not so much that we are replacing people. The concern is we are not overworking people. We're finding a way to allow people to do their jobs and be more effective. We're not seeing that kind of thing. We see this as augmented intelligence. It's a way of augmenting the human. Go back to the slide where I showed the three different legs of the stool, and you'll see the human is still very much in that. But just as we've done with everything in automation throughout history, we're elevating the role of the human. So instead of doing the repetitive task, we're elevating the human to do what humans do best, to use our own innate capabilities and our own knowledge and our own sensibilities, which is a much better use of humans than it is to have us keep doing the same thing over and over and over again. If you think about the Industrial Revolution, humans were essentially machines working on assembly lines. And now with the information age, we're able to liberate people to do more and be more and become more. So I don't see this as a threat. at least with the technologies available today. Your crystal ball may be better than mine, but that's not been the issue. The issue has been we have a huge gap and we don't have enough people to fill it. So it's not been an issue. The second question about the IP, the intellectual property. Think about the AI system the same way as if it was another person. If it reads the same, if you were to sit down and read all of this data and come up with a conclusion, then you could apply for patents or things like that. So I don't know that that's different. The thing is, an AI system doesn't have the same legal rights, so it would be whoever the owners of that are. There's a lot more issues involved in this than I probably have. I see I have 11 seconds left, which is probably not enough to give an answer to a legal question. So I think it's an interesting question. I don't think it's one that we've seen a huge issue with to this point, but certainly as the technology advances, we may run into those things. Right now, not a huge concern, as I see it. Thank you.
Gracias, Jeff.
Okay. All right. Thank you. Thank you very much. Thank you.